Indian Standard Time from the second launch pad. The mission intends to place Chandrayaan 3, weighing 3,900 kilograms, into an elliptical parking orbit having a perigee of 170 kilometers, an apogee of 36,500 kilometers, and an inclination of 21.3 degrees. Eventually, the destination of Chandrayaan 3 is the moon, located 384,000 kilometers away, which will be achieved through a series of orbit raising and course correction maneuvers over
की इलिप्टिकल पार्किंग ऑर्बिट में 21 डिग्री के झुकाव के साथ अंतक्षेपित किया जाना। दूसरा, पृथ्वी की कक्षा को छोड़ चंद्रमा की कक्षा में जाना। तीसरा, चंद्रमा की सतह पर लैंडर का सुरक्षित लैंड करना। और अंत में रोवर का चंद्रमा की सतह पर विचरण करके तात्विक तथा रासायनिक विश्लेषण कर वैज्ञानिक आंकड़े जुटाना।
On your TV screen, Honorable Minister of State for Science and Technology and Prime Minister's Office, Dr. Jitendra Singh.
जी हाँ, आज के मुख्य अतिथि के रूप में यहाँ उपस्थित हैं विज्ञान और प्रौद्योगिकी राज्य मंत्री माननीय डॉक्टर जितेंद्र सिंह।
We are about 31 minutes from the scheduled launch time. You're watching this live from the Mission Control Center. Apart from Doordarshan, you can also watch the launch event on ISRO website.
प्रमोशन तथा इस प्रमोशन की घटनाक्रम को पहले ही बताया जा चुका है। सर्वप्रथम दोनों S200 स्ट्रैप ऑन बूस्टर प्रज्वलित किए जाएंगे T0 पर। S200 के प्रज्वलन के 108 सेकंड के पश्चात L110 जो कि -2 मिनट तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू कर दिया जाएगा। L110 के प्रज्वलन के पश्चात करीब 100
-30 seconds. Real-time programs activated. -25 seconds.
L110 VSPB open.
-20 seconds. -15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal. P1
Here
tracking.
we have a majestic lift-off of LVM-3 rocket carrying India's prestigious Chandrayaan 3 spacecraft.
P2 tracking.
प्रज्वलन और सफलतापूर्ण LVM-4 रॉकेट का यह भीमकाय रॉकेट आसमान को चीरते हुए अपनी भयानक दहाड़ से चारों ओर कंपन उत्पन्न कर रहा है, जिसे हम यहाँ महसूस कर सकते हैं। और यही दहाड़ है जो वैज्ञानिकों को रोमांचित करती है। LVM-3 के उत्थापन के साथ ही हमारे अंतरिक्ष यान चंद्रयान 3 की चंद्रमा की यात्रा प्रारंभ हो चुकी है।
As the rocket is soaring through the clear skies, every second moving closer to the accomplishment of the most important milestone in its mission to moon. Every Indian witnessing the launch live is content with the feeling of watching history in the making.
चंद्रमा की सतह पर अपना छाप छोड़ने के लिए चंद्रयान 3 अपने मिशन को पूरा करने निकल चुका है। वर्तमान में दोनों S200 स्ट्रैप ऑन बूस्टर सामान निष्पादन करते हुए अपनी निर्दिष्ट कक्षा की ओर बढ़ रहे हैं।
S200 motors thrusting simultaneously, generating a peak thrust of close to 6,000 kilonewtons in vacuum. They are made
Please
of
change over to
HTPT
activity
based
two.
solid propellant. 204.5 tons in each strap-on. Close to 2 tons of propellant being burnt each second.
S200 स्ट्रैप-ऑन बूस्टर्स का कुल
L1 stage ignited.
प्रज्वलन काल 126 सेकंड का है और अभी घोषणा की गई L110 स्टेज का भी प्रज्वलन शुरू हो चुका है।
Apart from the
L110 stage
strap-ons,
performance normal.
the core stage has also commenced its operation. This stage, based on combination
200 stages are separated.
of hyperbolic earth storable liquid
कार्यरत है।
Hey, player one, do you think you're ready for this? Join Valorant.
और पूर्णतः सामान्य प्रदर्शन कर रहा है। अब हम प्रमोशन से 700 सेकंड की दूरी पर आ चुके हैं। सापेक्ष गति 6.5 किलोमीटर प्रति सेकंड, ऊंचाई 191 किलोमीटर।
As we have told you about the Chandrayaan 3's upgrades in the aspects of enhanced robustness through extensive ground tests and simulation, during the last phase of land
प्राप्त होते ही और उचित अभिव्यक्ति प्राप्त होते ही चंद्रयान 3 को अंतक्षेपित कर दिया जाएगा।
Cryo stage thrust cutoff. Satellite injection condition is achieved.
अभी पुष्टि की गई चंद्रयान 3 को प्रमोशन की कक्षा प्राप्त कर ली गई है।
Chandrayaan 3 satellite separated.
चंद्रयान 3 को सफलतापूर्वक अंतक्षेपित कर दिया गया है एलिप्टिकल पार्किंग ऑर्बिट पर।
Chandrayaan 3 has attained a major milestone success.
Chandrayaan 3 mission accomplished. Handing over to mission director.
Mission Director, the LVM-3 M4 Chandrayaan mission accomplished its precise satellite injection conditions. LVM-3 M4 mission is successful. Jai Hind.
The launch has also added a feather in the cap of LVM-3 rocket. You can watch the jubilant congratulatory gestures of ISRO scientists in the Mission Control Center.
जी हाँ, चंद्रयान को सफलतापूर्वक अंतक्षेपित कर दिया गया है, लेकिन चंद्रयान 3 की यात्रा अभी जारी है। अब इस मिशन के बारे में हम अध्यक्ष महोदय से सुनेंगे और हम आपसे आज्ञा लेते हैं।
We sign off.
Namaskar.
Up next is address by Secretary DOS Chairman ISRO.
Good evening to all who are participating in this platform. We are now live on Facebook as well as YouTube channel also. It's a most remarkable occasion when myself, Anjan Banik, addressing from Agartala, Tripura to you all in a celebration of Mission Chandrayaan 3. We are continuously interacting with scientists, learning from scientists about Mission Chandrayaan 3 because it's not a mission for ISRO. It's my belief that it can be motivating event for the students also who wants to be future scientists to enrich our tradition, our scientific heritage of India and our learning attitude. Even ISRO scientists is the most pioneer who are doing trial and taking lessons from their mistakes, and again they are trying to win the achievable goal or targeted goal, such like the south pole of mission moon. Again and again we are trying to achieve this one. In Chandrayaan 1 we succeed with our orbit. In Chandrayaan 2 again we succeed to achieve up to 2 kilometer away distance of surface of moon, though it is a crash landing, but we get maximum lesson how to enrich our science, enrich our learning about space science, etc. And this time also we have learned most and maximum to maintain a celestial object like our vehicle, our Chandrayaan, for 40 days, almost 40 days. It's a very miracle to all the global leaders, space leaders, that we are maintaining our Chandrayaan for 40 days, whereas today's great news, not a great news, it's a sad news also for science, that Russia's Luna 25, the scientists of Russia, Roscosmos, could not control their most believable, most powerful, most advanced technologically equipped Luna 25, whereas our scientists maintain that one. Today we are kept a most interesting, inspiring lecture. Also, our guest speaker, legendary scientist, Dr. T.V. Venkateswaran is also with us. Maximum who are now in the science communication field know Dr. T.V. Venkateswaran, but I would like to just brief again about him. Dr. T.V. Venkateswaran is a most pioneer scientist who is serving for the last some decades in Vigyan Prasar as well as Department of Science and Technology, Government of India. He has a keen interest in astronomy, astrophysics, and very specially associated with ISRO-like activities also. It's not only he interest in this, his own interest in this, he's also trying to communicating about this interesting science, space science and other things by guiding in preparing astronomical kits, telescope making and other trainings, as well as in science communication in different languages, local or regional languages also, for better science communication in India. Dr. I think we are going to talk scientists, ladies and gentlemen, make it happen with his presence at the ISRO control room and make a live commentary when Chandrayaan 2 launched and it is happening also. So today I am inviting our most beloved scientist, Dr. T.V. Venkateswaran from Department of Science and Technology. Welcome, sir. So many people are waiting to listen from you about your experience when you are in ISRO Command Center during the Chandrayaan previous missions, as well as this Chandrayaan 3 mission also. Now it has been already confirmed that India will be the first nation who may reach on the south pole of moon. Maybe it's a sad news for science because so many advanced technologies with Luna 25, but it is also
wait. South Pole region. Already Chinese craft has already landed in South Pole region. So there was no race between Luna and Chandrayaan. So what the media is saying that India will reach first is wrong information. If we had landed in 2019, we would have been first. Okay, so don't spread wrong information. Yeah, okay.
Great sir. Because I am also confused because so many fake news and other things, media craziness is there. So I think we have to learn and listen from you, from your side, and please start with your words of wisdom in this sense, because so many people are waiting for you, sir, and making so many comments. So I think I am disturbing also in your part. So carry on. Thank you, sir.
Let me try to share my presentation. I have uploaded the. Can you see my slide? Can you see my slide?
You press the present. No, sir. No.
Yeah,
sir.
I press the present.
Sir, you go to StreamYard's window, and here at the bottom, sir, one option is there, present.
Yeah, I press.
Click the present button.
The present button. It says share screen.
Then it shows entire screen.
Share screen.
Fine. It shows entire screen,
okay.
sir. entire screen. Click the entire screen, and again one window come. And now one window come here. Just at the right side, another entire screen is mentioned there.
Choose. No, there is only one entire screen.
On the screen, sir. One
Can you
window.
see my share now?
Yes, sir. Yes, sir. Your slide is now on screen.
Okay. So now can you see the second slide?
Yes, sir. You
No. Tell me what is in the slide?
sir, I am giving that is the slide in the slides, sir.
Yeah. Now I can. Now clear.
Orbiting, landing, hovering.
Now I can myself see. Perfect.
Okay, sir. Okay, I have given the slide on screen. You may not see the screen, but we can see the screen, sir. Now it is CY3.
Yeah. Fine.
You can start, sir. Thank you, sir.
Okay. Yeah. Thanks, Anjan, and thanks, friends who have joined this online program. So let me quickly go through some of the slides and then explain some importance and significance of this Chandrayaan 3. So whenever we are taking a mission to another planet or satellite, another celestial object to be more precise, whether it is a moon or any other planet, there are 4 kinds of missions which are done. One is called as a flyby mission, where you just fly near the planet and go away. Like there are many missions which have gone near Uranus, which has gone near Pluto. Okay, so they are all flyby mission. They don't land there or they don't go around them. They are flyby mission. Second, there are missions called as orbiter mission. So you orbit the planet or celestial object like an artificial satellite. The third type is lander. That is, you land, soft land on that surface. Fourth one is you carry a rover, which is like a robo car, and then move in the surface of that celestial object. These are the 4 types of mission that is usually done for a celestial object. Now, if you look at India, by Chandrayaan 1, which was done in 2008, we accomplished 2 out of 4. So what are the 2? We went near the moon. We also orbited the moon. So both of them are done. Out of the 4 possible missions, 2 are done. Okay, by Chandrayaan 1. So one need not repeat that. Okay. And what is this Chandrayaan 1 mission? The Chandrayaan 1 mission also had what is called as a moon impactor. Basically, it's a small, let's say, baby satellite, which was attached to the mother satellite. And one day, the small satellite was released. And that released object, because of the moon's gravity, fell on the moon. So while it was falling down, of course, it will fall down in a projectile motion. So you'll have a curve. Okay, while falling down, the impactor took a lot of photographs. In addition, when the impactor fell on the ground, it threw a big dust cloud. Okay, so those dust cloud was also analyzed by instruments on the orbiter. So this was part of the Chandrayaan 1 mission. So in a way, what is called as hard landing. That is, you are dropping some object into a celestial object. That also took place in Chandrayaan 1. So in the Chandrayaan 1, sorry, it's going fast. The Chandrayaan 1 had remote sensing cameras. Through the remote sensing camera, for the first time, detected water on the surface of moon, particularly in the South Pole region. Many people talk about South Pole. That is wrong. It is South Pole region. South Pole is a point. A region is from 90 degrees to 60 degrees. We all know about geography, right? So the poles are 90 degree. The equator is 0 degree, right? So between 90 degree and the 60 degree is called as polar region. So even in moon, we call it as moon's polar region. So in the moon's southern polar region, Chandrayaan 1 for the first time detected water. It was a big surprise because until then, nobody believed that there is water in the form of ice in moon. Okay, so it was a very, very major discovery. And the Chandrayaan 2, as we all know, I mean, it was launched in 2019. It had the second two objectives: flyby, orbiting, we have done. So the second two is land and also have a rover. And so that the Chandrayaan 2 had an orbiter which can go around the moon and then provide support to the lander. It also had a lander and a rover. This was a package that the Chandrayaan 2 had. We launched it in 2019. Somewhere in August, it attempted to make a landing on moon, and it failed. We all know about it. That in the last moment, the while landing, the craft management failed, and then it crash landed on moon. Okay, landing on moon is a very, very, very difficult stuff about which I'm going to talk later. Right now, I'll not talk about. But the original plan was like this: you land on the surface of moon. One of the walls of the lander will open up, become a sliding door, slide, and using that slide, the rover will come out of its belly and then move around the surface. This was the plan during Chandrayaan 2. And as we all know, unfortunately, this did not work. There was a failure at the last moment. Okay, the during the descent phase, there was a problem, and then it crash landed, just like the Luna. Also, we saw it this time, right? So it crash landed. Now, the debris of that crash landed material has been detected. So, learning from that failure, a new Chandrayaan has been made. Okay, number one, there is no orbiter in Chandrayaan 3 mission because the orbiter of Chandrayaan 2 mission is enough. So, we are going to use that. That's what is being put to use. But to take the Chandrayaan from orbit of the Earth to the orbit of Moon, we have something called as a propulsion module, which will propel from Earth to Moon. So you would have heard in news, you would have read it in newspaper that the orbit of the Chandrayaan was being raised when it was going around Earth. So for that orbit raising maneuver, you need energy. That energy was given by this propulsion module. Similarly, you would have heard in the last few days that the orbit around the moon was slowly being reduced. You know, August 5, it reached moon. From 5 to yesterday, the orbit of the Chandrayaan has been being reduced. For reducing also, you need energy, right? To apply a brake, you need energy, right? So that reduction of energy was also done by the propulsion module. On August 17th, the propulsion module and the lander separated. So after 17th, all actions of the lander module is being independently done. Okay. So until August 17th, from the date of launch, the propulsion module was providing the energy needed for the satellite to cruise to moon. That's the whole point. Okay. Now, this is the lander. As you can see, there are 4 legs. There are also 4 engines, 4 big engines here. Okay. There are 4 big engines. I hope you can see my cursor. Okay. So you can see the 4 engines on the underbelly of the Chandrayaan 3. So learning from the mistake, we have now improved the leg mechanism. So it's called as telescopic lens. You have this foldable umbrella, right? So you push it, it becomes small. You press a button, it becomes big, right? So it can go inside, right? It can slide inside. So these legs are also like that. So that when it falls, it can absorb the energy and keep the instrument safe. So the legs are telescopic arrangement. Okay, so it has telescopic arrangement so that it can absorb the energy from the fall. Okay, so that's the improved leg mechanism. Now, in the last mission, Chandrayaan 2 mission, there were 5 engines. Now we have only 4. There was a 5th engine in the center. That 5th engine in center has been discarded. Okay, now only there are 4 engines. These are called as thrusters because they give thrust. Okay, so there are 4 thrusters instead of 5. This is one major change. So these are the instrument on the lander. As you can see, there is a reaction wheel. There is a lander horizontal velocity camera. I will explain all of them. Don't worry. Okay, so I mean can you remove this? Yeah. Then there is a chased payload. Then there is a Ka band altimeter. Then there is a Ramba LP payload. I will explain all of them. Just I'm showing you the placement of these instruments. Okay, one by one, I'll be explaining it later. Then you also have a laser Doppler velocimeter. So this laser Doppler velocimeter has been added to Chandrayaan 3. It was not there in Chandrayaan 2. You have then laser altimeter. You have LRA. You have a star sensor. You have ILSA payload. There is a lander hazard detection avoidance camera. Then there is a 800 Newton throttable liquid engine. There are 4 of them. And each of this leg has two small engines, so there are 8 small engines also. Okay, so this is the arrangement of the lander. Okay, so now if you look at the rocket LMV3, LMV3 took the Chandrayaan from Earth to the space. Okay, Earth to the space, roughly about few hundred kilometers it took. It had 3-stage rocket. So what you see as pillars, 2 pillars here on the side, they are S200 solid engine. What you see in the center is the second stage L100 liquid engine. And what you see between these 2 black stripe, that is a cryogenic engine. That's a 3rd stage engine. This engine will start work only after the rocket reaches a height of about 100 plus kilometers. Okay. Below 100 kilometers, this stage 1 and stage 2 will give the enough power thrust for the rocket to go up. And after 100 kilometers, the cryogenic engine starts working, and then it gives the enough power for the rocket to go. So can you see in the top? Okay, it is inside this the Chandrayaan satellite is kept. Okay, the spacecraft is kept inside this. Okay, so this is what the launch vehicle, and we know that the Chandrayaan was taken to moon through a particular process. Okay, so when the rocket LMV rocket injected the Chandrayaan into an injection orbit, that is the first orbit, and after that there is an orbit raising maneuver. So you raise the orbit one by one, and then you raise it in such a way that this orbit goes to the moon. Okay, the height of the orbit is to the moon. Okay, so the moon comes nearby that when the craft goes there. So it becomes the moon captures it. So it comes under the influence of the moon's gravity, and then it starts going around the moon. So it starts going around the moon with about 18,000 kilometers away from the moon. It's a ellipse. So there is a near point, far point. No, the far point is about 18,000 kilometers. Then you start reducing the speed. Okay, you start reducing the speed and then make it into a orbit, which has been done yesterday, right? I mean, 25 kilometer, 115 kilometer. That is, when it is near the moon, it's about 25 kilometer. When it is far away from moon, it's about 115 kilometers. This was been that. And for this whole process, it took about 40-45 days. Okay, so we all know about it, right? The question is why? Why, for example, ISRO is taking 40 days, whereas, for example, the Luna took only 5 days, but of course it crashed. Long back, when Neil Armstrong was sent to moon, 4 days, they reached in 4 days. How? So there are different methods to reach moon. There are actually 4 methods. I'm not going to explain all of them. One method is called as direct. So what does direct mean? You have a very huge rocket with the huge power that it can give you, so that the satellite is given, the spacecraft is given enough thrust so that it can go to moon directly. Okay, so that's one method. The second method is what is called as gravity assist method. Okay, so India used something like a gravity assisted method, for which it took time. So let's understand what it is. Okay, let's understand what is this ISRO's plan. It's called as phased loop method for reaching moon. That's a technical term for it. Phased loop. Okay, it's like a loop. You go around Earth many times before you reach moon. Let's understand it using a swing. Let's assume that you are going on a swing. Okay, when you are on the maximum height position, you have a lot of potential energy, but kinetic energy is zero. So when you come to the bottom part, you have a kinetic energy, you don't have potential energy, right? And then again, when you go back, you have potential energy and no kinetic energy. These we know, and the potential energy and kinetic energy, in as long as there is no friction. Let's assume that this swing is swinging in vacuum, then there is no friction. So then potential energy and kinetic energy are same, so it will keep on oscillating forever. Newton's first law, right? Suppose if I want to increase the height of the swing, what should I do? How do I increase the height of the swing? If I increase the kinetic energy, automatically the height will increase, right? The swing's height will increase, right? Remember that, okay? That's some simple physics, our school level physics, okay? Because Ke equal to Pe. If I increase Ke by some delta K, then the Pe will also increase by corresponding level, right? So there'll be a height increase. How do we do it actually when you are swinging on the swing? When you are swinging on the swing, when you are swinging back, you use your foot to give a push under the ground, right? So you push the ground. So you are imparting some more kinetic energy. So now the swing goes high, little bit high. Then it goes up, and then once again when it comes, you again give a push. Then the swing goes still more high. Once again you do it, the swing goes some more high, right? So every time you can push only when you are near the ground. Remember that, okay? Only when you are near the ground, only when the kinetic energy is maximum. Okay? When the kinetic energy is maximum, that's when you have to push. Okay, where the potential energy is zero. Now imagine an elliptical orbit. In an elliptical orbit, the point where the craft is very near to the earth, and there is a point where it will be very far away from the earth, right? So the kinetic energy will be more when the object is very near to the earth. The potential energy will be less. The potential energy will be more when it is farther away from earth. Kinetic energy will be less, right? So you need to fire your rocket, the rocket in the propulsion module, so that a little bit more energy is added. Okay, you add a little bit more energy. So your kinetic energy has now increased. So what will happen because of the kinetic energy increase? The height of the ellipse will go up. Okay, so you will go the next loop, you will go even further away. So every time when the object comes back to the near point, okay, near point nearer to the earth, you operate the system, give some more kinetic energy, the satellite will go even up, then again up, then more up. Basically what you are trying to do is you are trying to make a ellipse where the nearby point is something like about 500 600 kilometer, and farthest point is something like about 3.8 kilometer 3.8 lakh kilometer 3.8 lakh kilometer. Why 3.8 lakh kilometer? That's a distance of moon. I'm saying rough, okay? I'm not saying exact number, okay? That's a distance of the moon. So once you go near the moon's gravity will become bigger than Earth's gravity, right? So the moon's gravity can now catch. But then you'll have to make this loop in such a way that when you are going to the farthest point in this ellipse, where the distance is more than 3.8 lakh kilometer, the moon should come there. That's a key point, remember. Okay, so you'll have to time it perfectly. That is why the satellites are launched at a given time. If for some reason you fail, you don't say that, okay, let's start after 15 minutes. You can't do that, because by then the moon would have moved away, right? So you'll have to make this calculation and then precisely launch. That's why the launch windows are fixed. Okay, so the principle that India used in Chandrayaan was something very similar to this. You know, something that you and I do when you play swing. That's a basic physics behind it. The gravity assist is also one more phenomena that can give more impulse to your engine. You need kinetic energy, right? You can give more impulse. How do I understand it? Suppose a train is coming towards you and you are throwing a ball at the train. The ball goes and hits at the moving train and then reflects back. Now, the reflected ball will be moving in much greater speed, right? Because there will also be the impulse of that train on the ball. You understand? Yeah, not only your hand's impulse, but the train's impulse will also be there on the ball. Okay, how did that extra energy come? That would mean that the engine would have lost a very small, very, very, very tiny bit of energy. Something that so minuscule that you cannot even calculate. You won't even see the difference. But then it can happen, right? So in the same way, when you are going around the earth or in an object, okay, if this is the direction of the movement of that object, like for example, the earth going around the sun, you make the satellite go like this in this red color, the satellite will gain energy because your earth will also be giving a push, right? So it will also give some more energy to your satellite, so it will gain energy. If you make the rocket go in this blue direction, okay, the earth will capture some energy and then the satellite will lose energy. So this is called as gravity assist. So this gravity assist phenomena was also there in Chandrayaan's launch. Okay. Yeah, so till now we talked about the launch. So let's go back to this story. So every time the spacecraft is here, Anjan, can you see my cursor? Anjan, can you see my cursor? Okay, I hope it can be seen. So whenever the satellite is in the near point, the propulsion module is operated, some kinetic energy is added. Okay, so it goes higher and higher and then it reaches moon. Now you turn the spacecraft and then now you backfire. Okay, you backfire. That is, you fire on the direction of your motion. So the spacecraft kinetic energy is reduced. If you reduce the kinetic energy, the spacecraft will slowly lose its height and then it will come toward the moon. Okay, so this is the principle of in which the Chandrayaan was launched. So this technology is called as a phase loop mechanism. Okay, so that's a mechanism that we use because our rockets are not very powerful. See, the LMV-3 rocket can take 8 ton to the low Earth orbit. That's what its capacity. But whereas the Russian rocket, which took Luna 25, or the Chinese rocket, which took to Moon, or the American rockets can take about 25 tons. We can take 8 tons, they can take 25 tons. That's the difference in the power of the rockets that each of this country has. So we have a slightly small rocket. So we said that it doesn't matter. Just because we are having small rocket doesn't mean that we have to sit in the side. Okay, we can think of a new way of reaching the moon. That is how this idea of phased loop mechanism was worked out. And then we started trying it right from Chandrayaan 1, not just Chandrayaan 3. Chandrayaan 1, Chandrayaan 2, Chandrayaan 3, and also Mars Orbiter mission. All of this are based on this phased loop mechanism. Okay, at gravity assist. Now let's look at what's going to happen on August 23rd. All of us, you, me, every scientist in ISRO, people who are actually working on managing this affair, everyone is in a very high tense moment, particularly after the Luna crash. Even most of us are, having sleepless nights. So what do you do? How do you land on a moon? Okay, so what's going to happen is like this. There are going to be 8 steps. This is a step 1. Step 1 will be from 30 kilometers to 7.4 kilometers. But of course, now we are not in 30 kilometers, we are in 25 kilometers. So this will slightly change, okay? But broadly, the idea will be same. So basically, you will come from 25 kilometers to about 7.4 kilometers. right? So how do you come down? You make your satellite horizontal so that the rockets are facing front. So when the rocket is fired in the front, there is an impulse that is generated backwards. Okay. So because of that, the speed of the satellite will come down. The speed of the spacecraft will come down. When the speed comes down, it will fall down. Okay, the orbit will reduce, so it will come down. So the speed of the spacecraft when it was about 30 kilometer will be about 6,000 kilometer per hour. 6,000 kilometer per hour. That's about 5 times the speed of sound. Remember that. Okay, that's the speed. So when it is reduced to about 7.4, the speed will come down to something like about 1,200 kilometer per second. From 6,000, it will reduce to 1,200. That is the first step. Now, the second step, here the main objective is to reduce your speed. Okay, that's your first objective. The second objective is navigation. See, I have a landing area in my mind. I should go and land there. Okay, suppose let's say you are going to your friend has moved to a new house and you are going to visit him or her. She sends you a location. You open it in Google Map, and then you see, I'll turn here, I'll go straight, and so on. The same way, there is a kind of a GPS in the Chandrayaan. I'll explain to you later. That will be used here to find where the craft is and in which direction the craft should navigate. Okay, so there'll be a navigational arrangement here. So two important aspects of this first phase is reduce speed and navigate. Okay, so let's look at this in detail later. So remember that that's the first phase. In the second phase, you remember in the first phase, the legs are facing forward. Okay, legs are horizontal. But then when you want to land, you want to turn the spacecraft so that legs are pointing downwards. Okay, so basically what you do in the second phase is you partially turn the legs. Legs are turned to about 50 degrees. Still not facing down, but turn to 50 degrees. During this phase, okay, during this time, the height will reduce from 7.4 to 6.8. The speed will reduce from about 1,200 to about 1,000. Okay. But most important thing, many instruments will start functioning. The instrument to find the height, instrument to find the velocity, etc. will start functioning at this stage. Okay, so this is the second stage. In the third stage, the most important thing will be to reduce the speed to zero. Okay, so by the time it comes to this point, the third point, the speed of the craft would have been reduced to zero. Speed in the horizontal plane. Okay, horizontal plane speed will be reduced to zero, and the craft would have turned down. So now the legs will be pointing downwards. Till now it was going like this. Now it will point out. Okay, so that's an important thing. And in this time, that is in this particular phase, many other functions of the Chandrayaan will come into play, like terrain navigation, hazard detection, and so many other things will come. I will explain them. Now you are in 800 meters above the lunar surface. So at the 800 meters above the lunar surface, you will make the craft hover. It will neither go up nor go down nor go sideways. It will be in one single place in the sky. Okay, at 800 meters, it will just hang. Okay, and then for about 12 seconds, and then it will slowly come down in a straight line. It will come to 150 meters. So once the craft comes to 150 meters, it will survey the ground, look for pits, look for dangers. It will avoid the dangers and then move to a place where there is no danger. Okay, and then it will start coming down. From 150, it will come to 60. From 60, it will come to 10. When it comes to 10 meters above the ground, all the engines will be switched off. Now the craft will fall like a stone. It will fall like a stone to the surface. Okay, so these are the things. So now let's look at what are all the phases. There is a phase 1. So that's about 30 or 25 kilometer to 7.4 kilometer. Then phase 2, 7.4 to 6.8. Then phase 3, that is step 3, 6.8 to 800 meters. Then the fourth one is 800 meters to 150 meter. Then the fifth one is 150 meter to 60 meters. Then the seventh one is 60 meter to 10 meters. Then you have 10 meter to ground. Okay, so these are all step by step maneuver. Let's understand why this is so and so on in the next few slides. Okay, Anjan, I want to ask you, can you see my cursor? I can't hear you.
Yes, sir. It is visible.
Excellent, excellent, good. So that's useful. So now I talked to you that in the first phase it will be using some kind of a GPS, right? So I'm going to explain that. So there is a lander navigation camera. I showed you. Remember in my earlier picture I showed you that. Let me go there and show you. It's better that we take a look. Okay, we take a look. So can you see the okay, so this lander horizontal velocity camera, this camera, okay, will help in identifying the position. How will it do? I'll explain. We have mobile phone, right? Sometimes in some mobile phone, you open and then show your face, the mobile phone will become active if it is your mobile phone. If somebody else shows the face, it won't active. So what do? Initially, when you purchase a mobile phone, you are taking your first picture and then recording that picture. So there is artificial intelligence inside this mobile phone, which takes features of your face. Like for example, the distance between your eyes, the length of your nose, the distance between your nose and the lips, and so on and so forth. These are all called features. Okay, so these features are collected, so and it stores. Next time you bring your face to the camera, your camera takes a picture, whereas your mobile takes a picture, again extract this feature and compare them. If the features match, it says that, oh, this is the same face. If the features don't match, it says that it's different face and then doesn't open. Same thing happens in the Chandrayaan camera. Let's go to the slide. So already the landing region, that part of the moon, a very detailed map has been given to the Chandrayaan. It's called onboard map. That map has been taken by the Chandrayaan 2 orbiter. Okay, so this photograph is already available in Chandrayaan. Now the Chandrayaan will take a photo of the ground. So that photo and onboard map, it will compare. And it will say that, oh, I am near here. It will compare and say that, oh, I am near here. So basically, the craft can locate itself on the moon. Okay, something like, for example, our Google map, that the blue dot tells you where you are in the city, right? The same way, this will do. So this is a kind of a GPS. Kind of, okay? So basically, it's called a navigational package. So this navigational package, which works on artificial intelligence, is there in Chandrayaan 3. Okay, so this is number one. Number two, I told you that you need to measure the height, right? How high the craft is. So for that, there are two instruments. So the number one instrument is called as, I'll show you that picture and then I'll explain. Yeah, so number one is here, this Ka band altimeter, okay, and the number two is here, laser altimeter. Okay, so there are two altimeters. So they measure height. How do they measure height? Both of them work in kind of similar principle. They send a pulse of ray, laser or Ku band radio wave to the ground. It reflects back. So when it reflects back, the time taken tells you how high you are, right? So that's what is used. The Ku band is used in the initial phase. When you are nearing the ground, you use laser. Because with laser, you can measure much more precisely and you need much more precise measurement when you are near the surface. Okay. So this is for measuring height. So this is the principle. So when the rocket is fired downward, the impulse of the rocket, which is in the black, is upward. That is the gravity of the moon. So by basically controlling the rocket's power, I can make this craft go up, come down, or stay in the same place. If I use the rocket with enough power, can counter the gravity, then the craft will neither go up or go down. So it will hover, right? So if I reduce the rocket power, then the gravity will be slightly higher than the upward push. So the craft will come very slowly. So how fast the craft will come down, I can control by controlling the engines. That's why it's called as throttable thrusters. So throttable means you can control. So you can control it. In the Chandrayaan 2, we can only control it in the step of 20%, 40%, 60%, 80%, 100%. Now you can control it in 10 degrees, 10, 20, 30. So even much finer you can control. So then you can make the craft more stabilized. That's the whole idea. Okay, so it's more controllable. Then I talked to you about hazards. Okay, so what are the hazards? Suppose we all know that on the moon there are craters, okay, which are like a pit. Then there are also boulders, which are like rocks. Okay, imagine my spacecraft lands on the moon, and one of the leg is inside the pit. Now what will happen? The craft will not be stable. No, it will tilt. Similarly, if one of the leg is on a boulder, on a rock, then again the craft will tilt, right? So you have to avoid rock, you have to avoid craters, big craters and big rocks. Chota, it's enough. That's not a problem. Big ones. How do you detect them? That is where the hazard detection camera, I'll show you. So here, can you see? Lander hazard detection and avoidance camera. This camera will come into play. What will it do? It will take images from the ground. Okay, images from the ground. For example, this is a crater. Can you see a shadow? Okay, shadow is like a face of a moon, right? Right. So the shadow. I know the angle of the sun, and from this shadow circle, I can find out mathematically how deep the pit is. I can actually compute, right? So by taking this photograph and analyzing this shadow, that camera, along with the artificial intelligence software, will check every crater underneath its surface. Remember, I told you that it will come to 800 meters and stay for 12 seconds, and then at 150 meters, it will stay for 22 seconds. During that time, it will survey the ground, and deduct deep craters, big stones. Stones also will cast a shadow, right? Okay, that shadow with that measurement, it will decide how high is the stone. So this is one artificial intelligence enabled hazard detection and avoidance. So if there is a place where there are a lot of the kind of pit and then stone, the craft will move away from it. Okay, move to a new safe place. Not very far, within 150 meters. Okay, within 150 meters, it can move on all sides to find a safe spot. Okay, so this is how it will work. So this is the area where we are planning to land. Okay, the Chandrayaan's landing site. This is where the Luna should have landed, but unfortunately it crashed. Okay, so this is where we should have landed. The Vikram lands crashed last time is also seen here. Okay, so on August 23rd, this is where we will be landing. If you look at the lunar missions, okay, until 70s, both Russia and America were going again and again to moon. Then afterwards, after about 1975 till 1990, there were hardly any mission. Nobody went. Then there were one or two mission. Then again from about 2005, there are lots of mission to moon. there are lots of mission to moon. So basically, there were lots of mission, and then some kind of an interval. Then again, the race to moon is taking place today. So people call this as second honeymoon. Okay, second honeymoon. Why? Why suddenly we are wanting to go to moon? One important reason is rare earth elements. Okay. There are some elements which are called as rare earth because it's very rare on earth surface. You cannot easily get them. Something like Ethereum and things of that kind. But all these rare earth elements are very important for the 21st century technology. You talk about laser, you talk about magnets, you talk about batteries, you talk about all of electronic goods. Okay, all of them need this rare earth element. On Earth, it's very rare. You don't find so much, but on Moon you have a lot. So one idea that people have is mining on the Moon. Okay, so the rare earth elements is used as catalysts, as magnets, as metal alloys. Okay, there are various uses for it. So if you want to mine this on Moon, okay, and then bring it back to Earth, I was talking to you about 4 different types of mission, right? What are the 4 different? Do you remember? That is the first slide. Let me go to the first slide. Can you remember this 4? Flyby, orbiter, landing, roving. Now, the world has come to understand that you need a 5th kind. What is this 5th kind? Sample return mission. What is this sample return mission? Maybe you can make this image slightly bigger. Okay, so then people can understand. So basically, you land on the Moon. Okay, so there is a rover which goes around, collects samples, brings it back to the mothership. The mothership puts it into a bag. On the top of the mothership, there is a launcher. So that launcher launches from Moon and then comes to Earth back. So you are basically landing on the Moon and then coming back to Earth. Okay, not the whole craft. Only one part of the craft will come back. The ground part will remain there. Okay, so the mothership's ground part will remain there. The top part will lift off and then come to Earth with the samples. I'm using the word sample because right now our satellites have only that capability. But in future, you can send capacities which can carry a capacity of something like about a few tons back to Earth. Okay, if you can create something which can bring back few tons, okay, our work is done. For example, there is a rare element isotope called helium-3. Okay, if you get 1 ton of helium-3, the energy requirement of India can be fulfilled for 1 year. 1 year, just only 1 ton. Okay, so this is called a sample return mission. So if you are going to look at the future of Chandrayaan, maybe not Chandrayaan 4, but certainly Chandrayaan 5 will be a sample return mission. That is, we'll land on the Moon, collect sample, bring it back to the Earth. Okay, so already America has done it, Russia has done it. Russia, I mean Soviet Union has done it, and then China has done it. Sample return. So India will also embark on that mission in future because that is what is needed if you want to mine and bring it back. Okay, so the imagination is that you can create something called as a space economy. You can go and mine Moon and then bring it back. Why suddenly we think that it is now possible? Why not earlier? Important reason, water. Yes, water. If you have water, I can split the water H2O into hydrogen and oxygen. Hydrogen can be fuel, oxygen you can smoke, breathe, right? So if I have water on Moon, I can take it, split it, I can create local energy. I don't need to bring petrol from Earth, right? You can make a local energy. You can create locally oxygen. So I don't have to carry tanks and tanks of oxygen, as was done in the case of Apollo mission. We carried the oxygen. Now you don't need to carry, you can produce it there. Now remember, The third stage of LVM rocket, cryogenic rocket. Do you know what is the fuel in cryogenic rocket? Hydrogen and oxygen, liquid hydrogen and liquid oxygen. So the same water I can use a rocket fuel. Okay, so if you have water, so many things can be done with it. Okay, and we know that there is water in South Pole region. That is why everyone is wanting to go to South Pole region. Okay, that's why we are also going. America is also planning to go to South Pole region. Luna was planning but failed. Already a Chinese mission has gone to South Pole region and has succeeded. Okay, so people want to go to South Pole region for that reason. Main. Okay, so that's the whole idea of mining from Earth. So if you want to establish a space colony in Moon, you need water. With water, you can create all this kind of energy and things of that kind. So you can easily work. Okay. So tomorrow, if you create a spaceport on Moon with much less powerful rocket, you can even go to other planets. Earth has a huge gravity. Okay, so you'll have to come out of it. But Moon has a very small gravity, so coming out of it is very easy. Okay, and it also no atmosphere, so there is also no atmospheric drag. So Moon is a good launching pad. Okay, so people are thinking that future space mission can happen from Moon, not necessarily Earth. Okay, so this is called as lunar gold rush. It's not actually gold is there, gold-like material. Gold-like material is that rare earth element I talked about, right? Including the helium-3 isotope. Okay, so people are thinking that you might get this from Moon, and that is why people are interested to go there. So with that, I'll stop. Yeah, I think I've stopped my presentation. Why it is not going away? Yeah. Yeah, I think a kind of an overview on Chandrayaan 3 and why we are going, what is the future, I think we have discussed. Is that right?
Correct,
Anjan?
sir. Correct, sir.
Yeah,
Correct,
thank you. With that, I'll stop. We can take few questions.
Yes, sir. You have some more slides or not? Because it is very much interesting also.
No. I think this is enough. We can have some more discussion.
Okay. So, sir, some question
See,
is.
I have spoken more than 45 minutes. So speaking more than 45 minutes is not a good idea. Okay. So we can
Sure,
have a
sure.
discussion that we
Sure, sir. Sure, sir. Some question has on screen, sir. Sir,
Yeah,
I am
please.
just and in my WhatsApp also. So
Yeah.
somebody
Comment
asked.
section. There are lots of questions. Let me read. Yeah, no, there is no question.
Arush Mishra.
Yeah.
Arush Mishra, he said, sir, this it's from his mother's account, sir.
Hmm.
These minerals can be found in ocean, which can be easier, and with correct precautions, we can do it much easier than moon excavation. So why don't we talk about it?
See, we have environmental concern on Earth because Earth has many living organisms. There is a huge ecosystem. Suppose if I disturb ocean, I don't know what's going to happen. Okay, I may think that I'm only doing a very small stuff, but its impact on the ecosystem can be very substantial, right? So what can happen is that we may destroy Earth. Now you may say that, what about Moon? But Moon does not have any living being, right? So there is no life there. So there is no ecosystem there. It's all inanimate. Earth is animate. Moon is inanimate, right? So that's why people are thinking that it's much simpler if we exploit Moon for resources than Earth. Because in Earth we will have to pay a huge price. I'm not talking about cost. I'm talking about future of humanity. Today we know that we are suffering global warming. Okay, if this global warming continues, the Earth will become a place where you cannot have humans living. Okay, so better not to destroy Earth. That's the whole idea.
And sir, another question from Tanvi Verma, hopefully from Chandigarh. Sir, what is optimal degree of angle to land on moon safely?
See, when the craft is landing, you want all the four legs pointing exactly ground ways, so it 90 degrees. That is straight down. That's what you want. But after landing, it may so happen that you have landed on a slope. Okay, so now the Chandrayaan 3 has been made such a way that if the slope is less than 12 degrees, it can be safe. If the slope is more than 12 degree, it may topple, so you don't want it. So it will be one of the hazards which will be avoided by that hazard detection camera. Wherever there is a slope which is more than 12 degrees, it will avoid. So people have found already places which are less than 12 degree. That is what it will choose.
Sir, one student asks about the AI system of the Chandrayaan 3. To
Yeah.
explain about it.
Yeah. So I explained, for example, about. Okay, let me explain another one. This is interesting. There is a camera that I told you, right? The horizontal velocity camera. So how does a camera compute velocity? How fast the craft is going? Let me explain it. Now imagine that you are standing in one place in a road. Okay, opposite to you there is a bus which is very far away, and the bus is coming towards you. So when the bus is very far away, it will look very small. When the bus is coming nearer to you, the image will become bigger and bigger and bigger. If the image is becoming bigger and bigger very slowly, what does it mean? The bus is moving very slow. If the image is becoming suddenly bigger and bigger, then it means what? It is moving fast. So from the how fast the image is zooming it up, you can compute how fast, what is the relative velocity. Okay, so this camera will take a picture of moon's surface and then look at how fast the moon surface is zooming in. From that, it will calculate how fast it is moving. It's basically a artificial intelligence.
Sir, another question. Sir, is there any AI system in Chandrayaan 2 also or not?
Yeah. Two also had a part AI system. Now we have improved it. We have additionally added more sensors so that the AI system can work better. It also had a AI system. Chandrayaan 1 did not have any AI system, but 2 and 3 had AI system. Rover also has AI system. Okay, rover, I'll explain because they wanted to know what is the AI system, right? Now let's assume the rover is going, okay, and there is a huge stone. The rover goes and hits, gone, right? So the rover sees that there is a stone, and it doesn't know whether it's going to hit or not, so it stays in the same place. Then there is no point. So the rover has to know what is the distance of this stone, right? How do you find the distance? You can use AI. Basically, you take two camera. Okay, I take two camera. Okay, so if there is an object here, this camera will be in this angle. In this camera, this will be in this angle. Now this is a straight line. This is like a triangle, right? So this is like a triangle, right? Right? I know this angle. I know this angle. I know this length. Can I find the height of this triangle? It's something that you study in mathematics, right? Angle, base, angle. You can find the height of the triangle, right? So the height of the triangle tells you how far the stone is, how far that big pit is. Okay, so you know that I can go up to that level. Beyond that, I should not. Right. So this computation is done through two cameras in the front of that rover. Okay, so this is also AI enabled. It's a AI enabled navigation.
Sir, another question came from a student that, sir, whether the Vikram lander will land on surface of the moon or south pole after sunrise, or it will land and then it will wait for sunrise.
No, it will land after sunrise, because if there is no sunrise, the hazard avoidance camera cannot work. Remember that it should have shadows. It'll land sometime around sunrise. That is when the sun is very low in the sky. Okay, only few degrees above the horizon, so that you will have big shadows. So if you have a big shadow, then it will be easy for you to calculate the height. Yeah, so that's how the plan is.
One question from our Facebook viewer. Sir, how much time does it take to reach the moon and land over there?
See, from about 30 kilometers to ground, it is going to take about 15 minutes.
And ISRO is saying that on 23rd, 6 o'clock, something around this time.
Yeah, basically the change from 5:45 to 6 happened because now we are not going from 30 kilometers to ground, but we are going from 25 kilometers to ground. Okay, so it's like basically, let's say there is a bus coming to the bus stop. Okay, the bus is speeding, and then it is coming near the bus stop, right? Suppose if the person in the driver is putting the brake some let's say 100 meters away, it will take some time for the bus to come and stop at the bus stop, right? But if you have to do brake only from 80, then you need only so much of time. No, not that's the difference. That's why there is also a time difference, because you want to come to the bus stop, you want to come to the landing spot. You don't want to land anywhere, right? You have to land at the landing spot. So you'll have to back calculate. You have to back calculate and then work.
Sir, one student asks whether this landing site is almost similar to the crash site of this Vikram, previous this Chandrayaan 2.
Kind of. It's not exactly the same place, but similar in nature. Very much similar in nature. That's what I showed you in picture. They are all somewhat in same area.
Sir, another question. This rover will work for 14 days, and
Yeah.
next 14 days, when it will be in night falls on moon, the temperature comes around minus 180 and 200. It may not work in for next 14 days.
No.
And
We expect it to work only for the first 14 days. That is until the nightfall. Until the nightfall, from whatever time that you land, because minus 200 degrees, the electronics cannot function. Okay, electronics cannot function. The Luna 25 had a radioisotope heater. Because it had a radioisotope heater, it can function for 1 year. Even during night, it will function. Similarly, the last few Chinese landers also had this radioisotope heaters. Okay, so they were also able to function for many months and years. ISRO is also developing this radioisotope heater. Maybe in our next mission, we will have this radioisotope heater.
Sir, he's also asking about what about the temperature during this lunar day during the third day?
During the daytime, the temperature is around 100 degrees, and during the night time, the temperature is around minus 200 degrees. I mean, take plus or minus for various reasons. Okay, but basically around that. Yeah. See, there is no convection on the surface of moon. In Earth, there is a convection. There is a air, so the hot air can move. Okay, so there is no convection. There is only radiation. Okay, on moon, there is only radiation and conduction. On the surface, there can be some conduction, and otherwise, it's only radiation. So, if there is no sun, it will suddenly become cold. Earth, it takes some time to become cold because the atmosphere holds heat, right? So, on moon, when the sun goes down, immediately it is dark, immediately it is cold. So, it's almost like within a second, from plus 100 degree, it will go to minus 200 degree. So there'll be a change of 300 degrees. Remember, yeah.
Sir, another question, sir. This Chandrayaan 2, which is orbiting, this orbiter is the main mid portion of communication in between
Yes,
ISRO
yes.
Center and
Yes,
Chandrayaan
ISRO
3.
Center will
So can
mostly
we
communicate. Yeah, ISRO Center will mostly communicate through the orbiter to the lander, and lander will also communicate. But for a fail-safe mechanism, there is also a direct communication. But normally, we would prefer to communicate through the orbiter so that you can get more data. If you directly communicate, you can only get much less data because the power of antenna on the lander is very small, so it can only transmit little bit of data. to Earth. If you want to transmit only to 100 kilometers, it is easy, right? So that's right.
Sir, one question is also related to this. He asked that what about the communication? How it conducted? The
Yeah,
signals
there are radio transmitters and radio receivers. Basically, radio transmitters and receivers. Okay, so everything happens only through radio transmitter and receiver, Ka band. So it's like our dish antenna. Okay, so the lander, the rover will communicate with lander. Lander will communicate with rover. Nobody else can communicate. They can only communicate amongst each other. And the lander will send information to orbiter, and the orbiter will send to Earth. Similarly, Earth can send to orbiter and orbiter to lander, or in emergency cases, you can directly communicate to lander.
Sanu Verma on Facebook, sir, want to know what is the mission life of lander and rover?
Roughly 14 days. Roughly 14 days. Maximum 14 days.
Sir, another question came. So many questions are floods. I think we have to take one or two, sir, because so many students and whoever joining they were curious about this one. Sir, we may conduct another session also after. I will take all the question and I will send to you so that you can prepare and we can conduct another session, sir. I think it will be last session, last question, sir, to you, sir. Whether only ISRO Bangalore is maintaining the this communication or other part of the ISRO centers are also doing this?
No. The communication center is only from ISRO Bangalore. But to communicate to the spacecraft, because Earth is rotating, the Bangalore may not be facing the moon at all times, right? Okay, so you have to face the moon if you have to send messages to moon, right? So what you will do is that there are also two other antenna of the NASA and European Space Agency. We have contact with them. One is in Australia, one is in Europe. So we send message to Europe or to Australia, whichever is facing the moon, and they will just send it. Okay, we'll be using that antenna to communicate, but the communication origin, communication message will be done only in ISRO.
Another question came, sir. It will be last, sir. Pardon me. Which launcher and lander is used for Chandrayaan 3?
That's not clear. The launcher, if you mean by rocket, it is LVM-3. That's what took the Chandrayaan from Earth to space. Okay, the lander is lander. There are 4 engines. I explained in the lecture, right? Yeah.
Thank you, sir. Thank you for being with us. You have joined us. You have given a so to the point solutions and to the point scientific enrichment slides, and very frankly discussion about the even you given examples, so which is maximum. I think student can understand better in such way. Sir, you are a great teacher, even more than scientist, sir. Sir, as I at the beginning also said, you are a legendary science communicator. So it's really shows in your act, sir. Thanks for coming, joining, and enrich our learning and listening also, sir. Thank you, sir, for being with us.
Thank you, and I also enjoyed the program. Thanks to everyone who participated, and also Anjan for taking this great effort. Thank you.
Thank you, sir. Thank you, sir. Thank you, sir.
Thank you. I'll take leave.
With these
Okay?
words, with these words, we are once again paying our regards and gratitudes to Dr. T.V. Venkateswaran, sir, the most legendary science communicator, scientist of Vigyan Prasar and Department of Science and Technology, Government of India. And sir is very much a good teacher also, I have to say, for the students who are interested, science loving students who are interested to and aiming to be scientists for future, to learn the science. Thank you, sir. Thank you for being with us. We are very much hopeful because all of your scientist dedication is there behind this Chandrayaan 3, and hopefully it will be success surely, and we'll get a very good result on the 6 o'clock 23rd August, and our flag, our national emblem will be spotted on the moon surface, on very especially on South Pole. And as you said, in future also Chandrayaan 4, 5, and 6 will be conducted under your guidance, under your supervision. Thank you, sir. Thank you being with us. Whoever enjoying these lectures, the series of on
I'll
moon
take leave.
mission.
Okay, I'll take leave.
Sure,
Thank you.
sir. Sure, sir. Thank you, sir. Thank you, sir. Thank you, sir. Who are enjoying these lectures on moon mission on this Facebook page or our YouTube channel, we are very much requesting to subscribe our YouTube. We have given in scroll bar, and we will serve the certificate of participation signed by scientists and other peoples to you. Please give your comment on YouTube channel after subscribing with this videos, and please mention your name and email here in YouTube channel comment box. We will prepare your certificate by next month, and it will be at your email also. So and also I would like to request you, please like, share, and subscribe the channel for the betterment, because your subscription to the channel makes a valued uh, inspiration, motivation to this initiative of communicating science, very especially space science. As well as I would like to invite all the students countrywide to join 5th year India International Sarabhai Student Scientist Award, which has been conducted as a preliminary round for the next year 2024, from 1st January 2024 to 28th February 2024 on National Science Day. As a first round, there will be a Google based password protected e-quiz round on astronomy and astrophysics, on ISRO, etc. And according to your score, we will select somebody for next other 4 5 step of assignment fulfilling, and on the base of cumulative score will confer the award for 2024. So all the students are invited who are interested to be future space scientists, wants to work with ISRO and NASA, etc. So with these words, once again I am sharing something for you. Enjoy this, and we will leave from this platform. This is the latest moon tracker, mission moon tracker Chandrayaan 3. Final lunar deboost burn completed, and it will land lunar landing by 2 days 22 hours, and it already passed its life 37 days 5 hours. And on the other side, the Luna 25 mission, it has been lost as confirmed by Roscosmos.
The National Award for Outstanding Efforts in Science and Technology Communication through Innovative and Traditional Methods, category E, goes to Shri Anjan Banik, Assistant Teacher, Agartala, all the way from Northeast. National Award for Outstanding Efforts in Science and Technology Communication in Electronic Mediums